Motion extraction tutorial for Unity Engine Part 3. Right now on the screen you can see the effect that we will achieve by the end of this video. In Part 1 I explained what motion extraction is and how it can be applied to game development with the focus on Unity Engine, and then we implemented the base effect, which you can see on the screen right now. It was first implemented in C# in Part 1 and then moved to a shader in Part 2. In this video we will be implementing the modified motion extraction effect, which is basically fancy colors. Instead of gray we will get some fancy colors that we will be able to customize. The current implementation of the effect, the one that we have after the Part 2, looks something like this. As you can see, there are two parts, CPU and GPU. Let's quickly go over it. It all starts with a camera which renders some image into a render texture 1. Then on CPU, this render texture 1 gets delayed and then transferred into render texture 2. So we have the current render texture or render texture 1 and the delayed render texture or render texture 2. The delay can be customized, meaning that it can be any number of frames. This is the CPU part. As we move from CPU to GPU, our render textures 1 and 2 become the current texture and the delayed texture, or A and B. For the delayed texture, or B, we invert the colors, getting B inverted equals 1 minus B. And then we get a sum of A and B inverted divided by 2, and this is our output that goes to the screen. And that's the effect. The problem with this effect is that it is just kind of boring. It's boring because for most pixels on the screen, A is almost the same as B, meaning that B inverted is almost the same as 1 minus A, and we get that the output is just 1 over 2, which is gray, which is boring. So let's make it less boring, and if we want to remove the boring, we need to remove the gray. And doing that is really quite easy. Instead of using the actual colors inside the textures A and B, what we do is we get the difference between them, or delta, between those two frames. So the delta is the difference between A and B, and for each individual pixel, delta is 0 when there's no difference in that pixel between the frames A and B, and delta is 1 when this pixel goes from completely black to completely white or the other way. So the minimum value of delta is 0, the maximum value of delta is 1. This allows us to define the color of the pixel for each value of delta that it can be. We can basically split the range of values of delta into sections, and for each section we can define a color. So C1, C2, C3, C4, C5. In this case we have 5 sections, so we have 5 colors. And we can also define the thresholds or each border of the sections. D1, D2, D3, and D4. And in code we will represent our sections as pairs of values of the color and the maximum border, and the last color will be Cmax. So for this example we will have 4 sections, 1, 2, 3, 4, and some Cmax that comes after all the sections. So now let's just implement it. In our shader let's define 3 variables. The first one will be an array of colors, so 4 colors. Then it will be an array of thresholds, float thresholds, let's say also 10, and then int number of sections, and by default let's say it's also 10. Oh, and also we need the maximum color, and this should be enough for us. We cannot expose the arrays through properties because properties cannot display arrays, but that's fine because all of those we will just modify from C# and we never need to look at those in Unity editor. Now let's write the actual code, the logic. First what we're going to do, we are gonna change the delayed color to not be inverted. We'll also define our float delta being the distance between current color and delayed color. That's our delta. And now we will do something illegal or slightly illegal. We will do a for loop inside a shader, and then we will unroll this loop, meaning that when the shader compiles, this will be just 10 if statements instead of a loop. That's why it's only slightly illegal. And it has to be a fixed number, so we actually are going to add an additional condition inside to not fire the unneeded iterations of the loop. So if I is less than number of sections, only in this case do we do anything. In other cases we do nothing. And the body of the loop will be just checking if delta is less than thresholds I. Then we set the color, or actually we can just return colors I think this should be it, yes. And then we can delete this variable, it's useless here, and at the end we return max color. So if none of the other colors were returned, we return the max color. Yeah, okay, I think this is it on the shader side. Now we just adjust our C# code to pass the values right here. In our C# script, let's define a public struct section and let's make it serializable. Inside this struct we want a color and a threshold. And now let's expose an array of sections to the editor and let's see if it's there. And yeah, there it is, the array of sections. And now let's apply those sections to our shader. So let's say we can have a function apply shader params, and to apply it we need to reference the material on our image. So let's create the public image, image, and yeah, we need Unity Engine UI for that. So here we do image material, and let's see, we have fixed for, float, int, set color array, float array, material set int, or set integer, I guess. So here we also need the maximum color that we did not define anywhere, public color max color. And now we can actually set those values. So for the max color, let's say max color, and here it is max color. So this one is easy. Then for the arrays we will need colors, new color, sections length, and same for the thresholds. So float thresholds. Now we want to iterate over the sections array, and like this and like this. We can now pass the colors into the colors array. So colors. Then here we do the same for thresholds, and here we do the integer number of sections. This will be sections length. And with this, I think we passed all the values that we need to pass. Let us just do that on start. Let's call this function on start, and let me think if we are missing anything. Let's just go and check it in the Unity editor. So let's set the max color as red, and let's set color 1 as, I don't know, half transparent blue with a threshold of 0.0.1, let's say, and then purple with alpha value of 1 with a threshold of 0.0.5. And let's not forget to assign our image right here. Now play, let's see what happens. Alright, and it works. The values are not great, we need to adjust those. I also noticed that the transparent color was not transparent. I think that's because of our shader. Yes, it's opaque. Let's say that it should be transparent, and blend src alpha 1 minus src alpha. Yeah, this should do it. Let's check. Yes, this now works pretty well. Now let's just adjust the values to make it look prettier. I don't like how much pink there is, so let's adjust that, and let's add more colors. So let's first set the max color to be something more pleasant, I don't know, like this. Let's make this less transparent for now. Then I guess we can increase the threshold for this. Let's say that it should be 0.1, and let's add more colors. Let's add 2 more colors for now, 0.15 and 0.2. No, not 2, 0.2. So let's say we go from dark blue to a little lighter purple, then we go to pink, then to red orange, and then the max color will be orange. Let's see how that looks. Alright, Yeah, I would say that that's better. I would say that that's much better. And I think with that, this episode is done. So as you can see, we achieved a pretty cool result. We have fully customizable colors for values of delta. Values of delta meaning how much motion there is for each pixel. It looks pretty cool. And with that, I think the work on the effect itself is pretty much done. There will be probably at least one more video where I will do some extensions, I will do the customization UI, and maybe some quality of life improvements, let's say, for the effect, so making it less visually janky when you move. That's one thing that I wanna explore. If you have any suggestions for what else I can explore with this effect, please let me know. Thank you very much for watching and have a great day.